Hi everybody. We are moving on to standard 6EE8. You might be thinking, wait, we're jumping backwards. Well, we don't follow the direct order of the standards. Last time we did the videos, we looked at standard 6EE9 about functions. Now we're moving on to inequalities. And you'll notice, oh wait, that's incomplete. I stopped writing there. There's more to the standard, but in this lesson, we're going to focus on this chunk here. We're going to be writing inequalities of the form x is greater than c, so comparing one value to another, or x is less than c to represent a constraint or a condition in a real world or a math problem. So the constraint or the condition is something that will impact the relationship between the values you're looking at. And then it's going to continue on, recognize that inequalities, blah, blah, blah. We're not going to get to that this lesson. That's why I stopped, but we'll come back to that. So we're looking at comparing values and representing that comparison based on the constraint or the condition. What affects the relationship between those two numbers? So we're going to start first by defining what an inequality is. And basically, an inequality is a statement. It's a statement that, it's a mathematical statement that establishes the relationship between two amounts that you're going to compare. So it's a statement that establishes the relationship between values and relationship between values that are unequal somehow, right? That are not, because if they were just equal, then we wouldn't be dealing with inequalities, we would be dealing with equations. Because an equation establishes equivalence, and inequality establishes inequivalence, if that's a word. We just made that up. Inequivalence. So the statement that establishes the relationship between values that are not equal because one is greater than the other, or maybe it could be equal, but there is still an imbalance of some sort between values that are not equal. Okay. So you guys should know these. You've seen these before, their review. The symbols we're going to be using are greater than, less than, so greater than, less than, greater than or equal to, less than or equal to. Okay, and what this means is, say for example, you are at a theme park, and in order to ride that one ride you really want to ride, you have to be at least 4 feet. Does that mean if you're right at 4 feet, can you ride it? Yes, because the language says at least. So this would be a greater than or equal to, because you have to be at least 4 feet. If I said you can be no more than 12 years old to, go to my classroom, no more than, does that mean a 13-year-old could come into my class? No. But if you are 12 or less, you could come into the classroom, right? So greater than or equal to, less than or equal to here. If I said the paycheck has to be greater than 5, that would be this one here. Not 5, but greater than 5. So important, this would be greater than. There's no gray area. It has to be bigger than that, whatever value you're looking at. This is less than. And this was at least. Some of the language you might see is at least. This would be something like no more than. It could be less than when whatever you're talking about, but it can't be more than that. So that's how some of these symbols will be applied. And other language, less than, fewer than, greater than, could also be more than. Squeezing it in here, guys. Less than or equal to, less than or equal to, greater than or equal to, at least, okay? And I'm looking at page 618, guys, if you want to see a table of this. Page 618, right there. And so in this lesson, what you're going to be looking at is values and deciding whether the values fit a number sentence. The thing about inequalities is that you have an infinite amount of solutions based on the relationship. Let me explain. If you have, and I'm looking at example number 1 from page 16, example 1, the question is, of the numbers 6, 7, or 8, which is a solution of the inequality f plus 2 is less than 9. So the question here really, guys, is whatever f is plus 2 has to be less than 9. It cannot be 9. So can f be 7? No. You know that because, and oh, that's one of the questions. So the values of 6, 7, or 8, question mark, right? We don't know. The question is, can any of these values be f? We know for sure 7 and 8 cannot. Why? Because f plus 2 has to be less than 9. So let's start with 6. I'm going to substitute, and instead of f, variable f, I'm going to write the value of 6, and plus 2 less than 9, question mark, because I'm checking that. 6 plus 2 is 8. And is that less than 9? Yes. So, yes, 6 can be a value, right? Because when I added 6 plus 2, it gave me 8, and I know that that's less than 9. How about the next one, 7? F plus 2 is less than 9. It has to be less than 9. That's the number of value we're working with. I'm going to substitute the 7 where the f is, plus 2 less than 9, question mark. I'm checking that. 7 plus 2 is 9. Okay, so is this number sentence true? No. No. Because 9 is not less than 9. 9 is equal to 9. So, nope, that can't be true. And then finally, you guys know 8 is going to be also not true because of what we saw here. Anything greater than 7, 7 or greater, makes this not true. But the other side of that is anything less than 6, 6 or less, would make this true. There is an infinite set of answers possible here, not just 6, right? If I substitute the f with 5, will I get a yes? Yes, because 5 plus 2 is 7, and that's less than 9. If I substituted a 4, a 0, a negative, guys, I would still get a yes. Anything smaller than 6, so to the left of 6 on a number line, would make it true. Anything to the right of the 6 makes it not true. So let's finish out this one here, though. You always want to prove your thinking. I'm going to substitute the 8 here, even though I already know, right? 8 plus 2 is 10. Remember, these are friendly numbers. 8 plus 2 gives me 10. And is that less than 9? We already know. Nope. 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 So that's a no, right? That's how we can prove that. You will substitute. So one thing that's important, guys, is when we're working with inequalities, we're dealing with these symbols and we're dealing with multiple solutions. That is fun. I really like the example of the amusement park ride, because if you want to ride an amusement park ride and it says you have to be at least a certain height, then say it's at least 4 feet, anybody who's taller than 4 feet could ride. That means I could ride. Yay! This is important to remember. You have the possibility of multiple solutions. And that's it, guys. That's the exploration in this lesson. You are going to be using the skill of substitution. Substitution, I'll show you guys one more example. But don't skip any steps, guys. This substitution is really important for what we're building up towards. I'll show you a few more examples from page 619. So if, with the inequalities, with greater than or equal to. So I'm going to pick number 4. If, I'm having a remix moment here. Example number 4 from page 619. Okay, so the question is, if the inequality is 17 is greater than or equal to 11 plus x, the question is, can x be a possible value? If x equals 8, can this statement, this inequality, be true? So our skill here is going to be substitution. We're going to substitute. Instead of variable x, I'm going to write the value of 8. Since that's what I'm saying here, this is the variable is equal to 8. And substitute it, bring everything else down. And I'm going to write my little question mark here because that's what I'm trying to prove, right? I'm trying to see if this is true or not. 11 plus 8 will give me 19. And is 17 greater than or equal to 19? It is not. So, no, not possible, not true. So the value of 8 does not make this true. It's too big. The value of x has to be smaller for this statement to be true. And that's it, guys. It's a yes or a no. Yes, is it true with this value? No, it's not true with this value. You will see some word problems in this practice, guys, and they all involve substitution. So if you look at example number 5, I'm just going to do one more. This one's super simple. In example number 5 from page 620, the question, I'll read it. Luisa works at a gift shop. She receives a bonus if she makes more than 20 balloon bouquets in a month. Which months did Luisa receive a bonus? Use the inequality B is greater than 20, where B represents the number of balloon bouquets made each month to solve. So B is the bouquets, and there's a table on page 620 where it shows the month and the number sold. So in the month of July, it says, according to the table, that she sold 25. So what I'm going to do is I'm going to write July. The question is for July, August, September, and October. And in this problem, you really don't have to solve anything. You just have to substitute. If this is our inequality, B is greater than 20. In the month of July, she sold 25. So if B is equal to the number of balloon bouquets, and I'm going to write 25 is greater than 20. Is this true? Yes, because I'm working with this inequality here. In the month of August, she sold 12. And remember, since B has to be greater than 20, 12, is that greater than 20? No, it is not. Nope, so my answer here is no. In September, she sold 18. That's going to be a no, because 18 is not greater than 20. That's a no. And then in October, she sold 32. I have here 32. I ignored my black pen here. 32 we do know is greater than 20. So in October, that was a yes. Right? And so there you have it. So let's meet in Schoology for your practice problems.